Hey, what's up, everyone? Welcome back to another episode of Stonks Maxxing. So it's day 170, I think 168 now, almost 170. And I have a pretty big term paper due this week for my economics class, my microeconomics class. Excuse me. And I decided to do mine on the semiconductor industry. So I think the idea is to just choose a paper topic, a research topic. Let's take a look. I want to make sure I get the same, I want to make sure I have the same thing, or I'm understanding this right. Okay, so I think one easy thing I could fix last time I didn't get a good grade on was actually the formatting of this. So let's quickly use Times New Roman 12-point font. Okay, yeah, this looks good. Okay, I just want to make sure I have, I remember my topic being mapping out the semiconductor value chain. Let's take a look. 75%. All right, let's see what happened. Doesn't tell me. I probably got something wrong on the graphing problem. It's not super clear, but yeah, not too great. Yeah, this one I got screwed over on. I did pretty bad. Okay, so there's gotta be like an ungraded, I think. Activities, maybe? Critical components, okay. Concise statement of the problem / topic. Okay, so I think this is kind of, let's see. Copy this down here. For this paper, I write to explain how the semiconductor industry has evolved since the supply chain disruptions from COVID in 2020. I write to I don't think I want to write about this. I think I want to write problem/topic. Summarize your position with an anticipation of the conclusion. To identify the key industries in the semiconductor value chain. Determine So for this paper, I write to identify the key industries in the semiconductor value chain and classify and classify the underlying market structure of each industry. More specifically, identifying if there has been For this paper, I write to identify the key industries in the semiconductor value chain and classify each of the industries' underlying market structure. Still sounds kind of weird. More specifically, identifying if there has been a geographic shift in any More specifically, let's say identifying countries that dominates certain parts of the value chain. Classify each of the industry's underlying market structure. More specifically, so this process involves understanding the key countries that are leaders in and countries and companies suggests there are 3 key industries that are worth studying. That's suggests there are 3 key industries that are worth studying to understand the semiconductor value chain. That are serve as the foundation for the semiconductor value chain. 1, semiconductor design. Okay. I think this is where I could probably add this. So, industry that will design architectures for chips. Three key industries that serve as the foundation for the semiconductor value chain. Okay, so there's 3 different ones: semiconductor design, semiconductor manufacturing, and equipment. I have this nice chart. Maybe in this section I could talk a bit about Okay, I think maybe this section I'll talk a bit, very high level, each of these different industries, and then the classification I gave to each. Specifically taking a look at monopolies, semiconductor manufacturing, and then oligopolies in semiconductor design and semiconductor equipment. So I think that would probably, I can't talk. I think that would be a pretty good point. So section on summarizing position about each classification, countries, country leaders. And then we can go into the understanding the basics and then the analysis. Okay. The chart above illustrates my current position on the three major industries. The three major industries. Semiconductor, two different types of oligopolies and then monopoly. Right. Few firms dominate the industry, which results in, I think this is probably where I would want to understand how the underlying costs let's see, learning. Firm dominates industry. Let's dominate the industry. Semiconductor design and equipment. Share this market structure. Right, so I want to say each of these companies, kind of like the design and equipment, they all have intellectual properties that are a cornered resource for them. So each company is protected by intellectual property. Skilled human capital. I don't know if capital is a big, I guess maybe for equipment and medium capital requirements to achieve long-term scale requirements to achieve long-term profitability. These monopolies were formed with the support of governments and industry participants. So when I think of government, I'm thinking of TSMC, and then the industry participants, I'm thinking of ASML. Because I think ASML was started as a consortium of semiconductor companies that wanted to invest in EUV, but it was pretty expensive for a single company to do it. On the so maybe talk about geopolitics now, basically seeing who the country leaders are in semiconductor design, manufacturing, equipment, right? I guess it'll be interesting to identify the country leader, so to speak. Okay, so now that we talked about this, chart above illustrates my current classification into two different types of market structures. Got it. When I don't know how to phrase this, so talk about geographic considerations. Considerations. Try to isolate country leader to just one instead of multiple. I can't spell. Okay. Let's set the stage first. Traditionally, semiconductors refer to elements and materials that act as both insulators and conductors, allowing the flow of electricity to start and stop on command. In this paper, the word semiconductor refers to the electronic integrated circuits that are used to control modern electronics today. Often used the term semiconductor is often used interchangeably with chips or ICs. All of them mean the same thing. The ubiquity of semiconductors in everyday life is often unnoticed, hidden underneath a keyboard or a screen. Yet, in 2024 alone, nearly 1 trillion semiconductors were sold globally, more than 100 chips for every person on Earth. This industry is massive and underpins next-generation technologies, from vehicle to AI foundation models, making this one of the most important sectors in the entire world. Now that the stage is set, let's dive into the economics. Okay, I think this is actually pretty good. Semiconductor design industry focus on the what's another word for design? Building the blueprint for the semiconductor design industry focuses on building the blueprint for semiconductors eventually manufactured further down the value chain. Semiconductor design industry focuses on building the blueprint for semiconductors that are eventually manufactured further down the value chain. Okay, I think that's actually a pretty good. Today, this industry is dominated by 5 major players: Broadcom, Intel, NVIDIA, AMD, Qualcomm. $120 billion. I think that's even more. Yeah, NVIDIA alone was 130. So I'm not entirely sure where they're getting the number from. Yeah, Intel products I can just add on here. Semiconductor solutions. Okay, I'll call this the semiconductor design revenues. NVIDIA computes, NVIDIA revenues, AMD revenues, Intel products revenues, Broadcom semiconductor revenue, Qualcomm semiconductor revenue. Okay, 2024. Value. I guess we could use this as a proxy, maybe? Like the 220. Logic, analog OSD, microcomponent. Hey, my friend just finished his first marathon. That's pretty cool. Okay, I do want to find the 10K Let's see if there's a breakdown of revenues for Qualcomm. Okay, equipment and services, QCT revenues. Okay, I guess it's the licensing. Total revenues, QCT, and then QTL, 24, 33196, 30382. Okay, so we'll do Qualcomm QCT. Total. And then we could also add the PWC estimated total addressable market, estimated market size, So we are kind of oh, this is actually very, very helpful. So let's add up, I'll do logic. I don't know a microcomponent. I think this is optics, sensors. Okay, add up maybe the analog. I don't think any of these guys do analog, but that could be more of an integrated device manufacturer. Logic, I guess microcomponent could be included. So let's do micro components, logic, to, let's see, 220 and 96. So we can try to get the percent. So 80% of the market, of our market, is dominated by, yeah. Account for around 85% of the total revenues in the industry. So I do need to make specific references to the textbook, I believe. Oligopolies. I think with double space, I should probably also target like 5 pages in the body. Okay, let's take a look. There's this N ratio. The 5 firm concentration ratio is telling of the balance of power in this industry. Five firm concentration ratio is telling of the balance of power in this industry, where only 5 companies represent around 85% of the total revenues. Only 5. Total revenues. I'm not entirely sure what I should kind of move on here. Should I explain why this exists? Or should I continue explore why this exists, or explore why this should continue exploring how this resembles a oligopoly. Oh, okay, and then mention semiconductor design. Protected by IP. R&D costs. Right, I think these are also different ways to look at it. Each of these companies, companies compete fiercely with each other in many overlapping end markets. including PCs, data center servers, call them servers, automobiles, these companies compete fiercely with each other in overlapping end markets, including PCs, servers, automobiles, and consumer electronics. In order to differentiate their products, each company specializes in design architectures with the goal of maximizing performance while minimizing costs and energy requirements. Computing performance while minimizing costs and energy. Monetary and energy costs. There we go. Okay. I have every single sentence starting with a T. These companies compete fiercely among each other. Goal: maximizing company performance while minimizing monetary energy costs. I kind of want to talk about the R&D. If I can get the R&D expense of all of these companies in 2024, maybe beyond 2024. In just the past 3 years, right? So R&D costs past 3 years. A closer look at the R&D spending of each of these companies reveals that illustrates how much capital needs staggering amounts of capital that needs to be invested in order to stay competitive in this industry. I guess I want to write something that says semiconductor companies can protect their spending, or they're often rewarded, right, of spending billions per year on R&D. Semiconductor companies are rewarded with high operating margins that can be protected with patents for entry for new entrants, prevents new entrants from entering the market. Okay, so I think this could be good. The number behind TSMC, okay. The semiconductor manufacturing industry focuses on manufacturing the actual semiconductor chip after it is designed. After the design has been complete, there are this industry can be bifurcated into two segments. One, advanced manufacturing. Two, mature manufacturing. This industry today, this is bifurcated into two segments. Hmm. 7 nanometers manufacturing. Acquire the smallest details below these. So manufacturing process for advanced chips that require the smallest details, smaller than 7 nanometers. Manufacturing process for, we'll call them legacy chips, that finest details, often used for computers, smartphones, and servers. Less fine details, often used for automobiles, consumer electronics, IoT devices. Okay, so we've identified the two, we'll call them subsectors within the manufacturing industry. And now I kind of want to focus on the advanced manufacturing and understand why is it a monopoly, TSMC, and then detailing maybe the supply and demand dynamics. Especially for advanced manufacturing. Okay. Also, price elasticity. Yeah, I have that. In my original statement, I chose to focus on the advanced manufacturing segment of the industry, where only a single company dominates, TSMC. Ooh, okay, so maybe a Nash. Road to becoming a monopoly in advanced manufacturing. Monopoly in advanced manufacturing. TSMC's road to combines elements of national policy, forces. Natural market forces. Okay. The semiconductor, let's see. TSMC's road to becoming a near monopoly in advanced manufacturing is a result of national policy and natural market forces. From its beginning, TSMC was championed by the Taiwanese national government. From its beginning, TSMC was championed by the Taiwanese national government. I believe they provided funding to the initial seed investors, and then over time gave it grants, tax credits, and also probably favorable regulation permits. Let's see, Taiwanese government. Oh, TSMC. Okay, so chip war. Which helped provide the initial capital to build the first manufacturing plants in Taiwan. So we'll call it chip war. As the company continued to expand, the Taiwanese government helped support, continued to support the business by offering grants, tax credits, and favorable regulation. Okay, so that's on the national policy side. I think on the natural monopoly side, we have to talk about the scale at which the cost of these fabs ended up rising over time. I think it got exponentially more expensive. natural market forces from okay. Within the market, I don't know if I should talk about the foundry business model versus the IDM business model. That's actually something I'm not entirely sure if it should mention too. We'll call it within the market. The trend organic trend was emerging among manufacturers at the cost producing of advancing technology production was getting exponentially more expensive, uncomfortably expensive. An organic trend within the market, an organic trend was emerging among manufacturers at the cost of advancing their technology production. Their semiconductor production was getting uncomfortably expensive. Semiconductor companies were using sales producing chips they designed during using profits to reinvest back into fabrication side. During the 1990s and 2000s, were manufacturing the chips they designed. And use the profits from selling their products to reinvest a trend was emerging among these companies that the cost of process was getting uncomfortably expensive. Okay. It's getting uncomfortably expensive and unsustainable for long-term profitability. Naturally, they turned TSMC to help improved allowed TSMC to achieve economies of scale that lowered their cost of production compared to the rest of the industry. Marginal cost compared to the rest of the industry. Okay. I guess long run average cost declines. As you produce more. Okay. As output scales. Okay, so we can calculate long run average cost as total cost divided by number of units. So I guess in this case it could be wafers sold. That'd be nice to insert a chart here. Okay, on that. Okay, so how is the stream going, by the way? Doing this for about an hour and 30. All right, not bad. I think what I'm gonna do is do this for another 30 minutes. Go for a run or a walk outside maybe. It's a pretty nice day. And I'll get back to this. So we have 1, 2, 3, okay. The semiconductor equipment industry focuses on building used during the manufacturing process. Used during the semiconductor manufacturing process. So within the industry, there are different parts of the process that companies typically there are different parts of the manufacturing process that companies specialize in. Etching, cleaning, testing, So etching, cleaning, testing. I think planarization is another one. I know photoresist is another one. Yeah, there was that one thing on Canva that we made. That was pretty helpful. 6 different types of categories focused on, I think this is from branch education. Yeah. Mask layer. Oops. Photoresist, spin coats, cleaning, photolithography, etching, photoresist removal, metal deposition. I think that's adding materials, right? Drawing patterns on conductor chip. Removing, adding new layers onto a chip. If you imagine, so I'm going to focus us on building equipment, on providing equipment used, designing and manufacturing equipment used during the semiconductor manufacturing. the actual process, of manufacturing semiconductors is like baking a cake with multiple layers. With multiple layers. The semiconductor equipment industry focuses on designing and building equipment used during the semiconductor manufacturing process, and the process is like baking a cake with multiple layers. So how do I kind of wrap this up? The industry, there are different parts of it. Focusing on one layer at a time. Lots of steps in each. There are lots of steps in each intermediate steps in each layer. That requires a unique set of tools. Can be broadly classified to the following areas. From semiconductor cleaning, removing any dust particles and testing, ensuring each step has not caused any problems. Okay. All but one of these equipment have an oligopoly structure. All but one of these types of equipment. Oh. Sub-industries has an oligopoly structure. All but one of these types of equipment sub-industries has an oligopoly structure. Okay. All but one of these equipment sub-industries has exception is photography, where one company, ASML, has a monopoly. Okay. So one company, ASML, has a monopoly in advanced machines. Okay. So for yeah, let's kind of see where we are at right now. Okay, not terrible, not terrible. Okay, so I think we can kind of do a similar analysis in so run similar analysis as above. In each of these sectors. So N ratio concentration and N ratio concentration R&D. R&D faction. Okay. Okay, so with that being said, I think I'm gonna end this stream here. Doing a bit early. I kind of need to use the bathroom though. So I'll be back in a sec. Peace.